Okay, this is Module 31, Ratios, Proportions, and Geometric Mean. First thing I have to do is I have to define what a ratio is. And a ratio is a comparison of two numbers, and it can be written as either A over B or as A semicolon B. The thing is, it has to be in most simplified terms, and it has to have no units, so the units will have to cancel out completely. Alright, so for the first example, we have 64 meters, semicolon 6 meters, and we're asked to simplify the ratio. So, first thing we have to do is we rewrite the actual ratio as a fraction so we can cancel and simplify. I notice that we have the same meters, so that is going to cancel out first. And then you're going to also notice that the two numbers are both divisible by 2. And if you divide each one of the 64 and 6 by 2, you will get 32 over 3. Or you can rewrite it as 32 semicolon 3. And that's your finished ratio. And either one of these answers is going to be accurate, is going to be correct. So what about B? Simplify a ratio with unlike units. You have to multiply by the conversion. This is something that was an indicator in Algebra 1, simplifying and making cross cancellations. So we have 5 feet to 20 inches. So 5 feet to 20 inches, the thing that you should know, or if you don't, you know hopefully now, is that there is 12 inches in 1 foot. When you are doing conversions, you need to make sure that your feet, the like units, are going to be across from each other, inches and inches across from each other as well, so they cancel out completely. After you do that, then you can start simplifying. You can multiply straight across, or you can do cross canceling. In this case, I see that 60 is actually divisible by 20, so you get 3 over 1. And keep it as 3 over 1, because you want to write it as a fraction. Okay, so we have simplify the ratio, 24 yards to 3 yards. Well, they have the same conversion, so they have the same units, so all you do is cancel them out, you get 8 to 1. Centimeters, there's 100 centimeters in 1 meter, so that's what I can give you, 100 centimeters for every 1 meter. Use that conversion to solve, and your answer should be 1/4. Okay, so we have another example. You are planning to paint a mural on a rectangular wall, and you know that the perimeter of the wall is 484 feet, and the ratio of its length to its width is 9 to 2. Find the area of the wall. So, first thing you have to do is write the expression of the length and the width. Because the ratio of the length to the width is 9 to 2, you can represent the length by 9x and the width by 2x. Again, this is something you've done in Algebra 1. So, once you do this, solve an equation to find x. We know that it's perimeter that's being asked. So you need to know what perimeter is, distance around. So the perimeter of a rectangle is 2 times the length plus 2 times the width. Once we have the actual formula, you can plug in what you know, use substitution, and solve for x. When you solve for x, you get x equals 22. But it says find the area of the wall. So just finding 22 is not the entire answer to the problem. Find the area of the wall. So that means you have to evaluate and use substitution into each one of the lengths and the widths. So when you do that, the length is 198. The width will be 44. And then area is going to equal length times width. So that gives you 8,712 feet, and it's feet squared. You have to be specific with units in this particular chapter. Okay, next example is called using extended ratios, and it says the measure of the angles of a triangle CDE are in the extended ratio of 1 to 2 to 3. Find the measures of the angles. So, solution for this is you begin by sketching the triangle, draw the triangle, use the extended ratios of 1 to 2 to 3, and you're going to label each one of the values as x, 2x, and 3x. So that's 1 twice it and then 3 times it. So here's my labeled figure. So I have x to 3x to 2x. And you have to ask yourself what the area or the angles of a triangle add up to. And that was a triangle sum theorem. So now perform algebra, collect like terms, or use substitution, and solve for x. What the question is asking is finding the measures of the angles, which means you have to solve for x first and then actually use substitution to find out what each one of the angle measurements are. So we have a 30, twice the x is 60, 3 times the x is 90, so we have a 30, 60, 90 triangle. Okay, so we have the perimeter of a room is 48 feet, and the ratio of its length to its width is 7 to 5. Find the length and the width of the room. We also have a triangle angle measures are in the extended ratio of 1 to 3 to 5. Find the measures of the angles. Those are your practice. So try and use the example to figure out what 3 and 4 are. So if you did it correctly, you should have gotten 14 feet and 10 feet. The length is 14 feet, the width is 10 feet. And for the extended ratio, you should have gotten 20 to 60 to 100. Okay, proportions. This is a very, very useful skill, is setting up proportions. What I have to do is I have to define what a proportion is. And all a proportion is an equation that states two ratios are equal. So if you see this one here, that's ratio 1, that's ratio 2. And you solve by cross multiplying. And this is, in a previous module, I told my kids to make peanuts. So cross multiplying or making peanuts. So we have the first one, 5 over 10 equals x over 16. So the solution to that, you set it up obviously, and then you use your peanuts. So using your peanuts, cross multiply, and you should get 5 times 16 equals 10 times x. You simplify and then solve, divide by 10, solve for x to get x is equal to 8. For the second one, you have to use the distributive property, but again you use peanuts. So cross multiply, and once you do that, make sure you use the distributive property. This is a mistake that I see a lot of my kids doing. So you have 2 to y and 2 to 1. So when you do that, you simplify it, you get 3y is equal to 2y plus 2. Then we have to get the y's on the other side, so we subtract 2y on both sides, and we get y is equal to 2. So here's some more examples. So use cross multiplication on each one of them, and you can check and see if you're doing the correct work. Here's the answer to the first one, the next one, and then the next one. So check and see if your work is matching up and you are getting the right answers. If you're not, that means you're making an algebraic error. Okay, so another example we have, as part of an environmental study, you need to estimate the number of trees in a 150-acre area. This is why proportions are so useful. You can use them to kind of estimate what's going to happen in the future. So this is one example of doing it. So you count 270 trees in a 2-acre area, and you notice that the trees seem to be evenly distributed. Estimate the total number of trees. The thing that I tell people is you have to make sure that you're consistent from ratio to ratio. So when you set this up, you have to write the proportion and compare the number of trees with the area of the land. So first step is take what they give you. You're trying to estimate the number of trees in a 150-acre area. That's an important piece. You also count 270 trees in a 2-acre area, so you can use that to set up your proportion. 270 to n, or 270 to 2 equals n to 150. The thing is, you need to keep your trees to acres. Trees to acres. If you switch that on one of them, you're going to cross multiply and you will get the wrong answer. You're comparing two and then comparing the two ratios as well. So you need to be consistent top to bottom and not change it from one portion or one ratio to the next. So again here, cross multiply and solve. So when you use the cross product, you simplify and you solve, you get n is equal to 20,250 trees. That's the estimated total number. So okay, so this is it in a sentence. There are about 20,250 trees in a 150-acre area. Okay, geometric mean is, all it is, it's basically two numbers multiplied and you take the square root of those two numbers. Now there's a couple different ways that I will accept answers with this. Some people like to plug it into the calculator. Others like to use simplest radical form. And I'm going to give the example of both. So we have solution. You multiply the two numbers, 24 and 48. So I multiply 24 and 48. So you have to figure out and break down, this is simplest radical form. So you break down 48 into 24 and 2. So this is what 48 was. And then what I notice is that you have a group of two 24s. So in a square root, if you have a group of two, that means one of them is going to come out, and you're left with 24 root 2. Root 2 does not have a pair, so he's left underneath. This is, again, think of it as a couple. If you have a couple, that means they get to leave and go off on a date outside of the square root. The 2, he's lonely, so he has no date. So he stays underneath the square root. So he's sad. So that's simplest radical form. The other thing you could have done is just plugged it into your calculator, whatever 24 times 48 is. And if you did that, 24 times 48 gives you 1152. So, and then you can just plug in the square root of what 1152 is. So taking the square root of 1152, you would get in your calculator 33.9. Now, this one here is actually a more exact answer. This one here is acceptable, but it's an estimation. So if you ever become an engineer, they will not like the decimals. They will actually like the radical forms. So, because they're more accurate. Okay, so we have the geometric mean of the two numbers. So we have 12 and 27, 18 and 54, 16 and 18. So you can do those on your own. You should get the answer for 18 for number 9. 18 root 3, again, this is simplest radical form for 18 and 54. And 12 root 2 for 16 and 18. So check to see if your work actually matches up with the answer.